All right, let's take a look at polynomials. Polynomials are fun because the graphs kind of look like roller coasters when you're done graphing them, which I'll show you here in just a second. But as you're the two big ideas are going from equations to graphs and from graphs to equations. So the big learning goal, number one, is you'll be able to look at an equation just like this, okay? That's a polynomial equation, and you'll be able to graph it by hand with a quick sketch. The second big idea is that you'll be able to look at a graph, so you'll have this fun looking roller coaster kind of a graph, and you'll be able to build its equation. All right, there are 5 key ideas or 5 key terms, and I would encourage you to definitely write these down, as these are the big ideas of this start of the polynomial unit. The first key term is root or 0. And basically that is the spot or the x-intercept of the graph, where the graph would hit the x-axis. So where it hits the x-axis found by using the zero product property. So an example of that would be if I had this equation y equals x plus 3 times x minus 2, that would hit the x-axis at -3 and +2. Because this zeroes out when that is -3, this becomes 0 when that is 2. That is something that you should know already kind of coming into this chapter or course. So if we take a closer look at that, if I was going to graph this, then at -3 it's going to hit the 0, and at +2 it's going to hit 0. Well, the shape that does that then is found by an x squared equation, which we call a parabola, and we know that because we know how to do generic boxes. If I was going to multiply these out, that's what I'd have anyways. So then that's going to make this parabola kind of shape. It's going to hit at those 2 spots. The degree of the polynomial is equal to the highest power of x in the equation in standard form. So also equal to the number of direction that the graph goes. So we're going to be looking closely at the degree, and we're going to be counting the directions. So let's take a look at what that looks like. So we already did this problem before. We had this times this in factored form, which made this in standard form. Well, that right there is the highest power of x, that 2. Because if you multiply these 2 binomials together, they make an x squared term. That 2 becomes the highest power. The power that's on this x is 1, and there is no, this would be like x to the 0 power, but there really is no x here anyways. So the highest power being 2 means that the graph has 2 directions. It starts up here in this corner. We always read things from left to right, and it goes down until it hits the vertex point down here, and then it goes back up. So it goes down and then up. So it has 2 directions. So the highest power tells us what the graph is going to do for the number of directions it's going to have. Next, a polynomial. A polynomial must follow the format of any number times a whole number power, plus and minus whatever, you keep repeating that pattern. So if we're going to take a look at what that looks like, here is any number and an x to a whole number power, a number with x to a whole number power, and so on. It's basically going to look like that if it's multiplied out for you already. It cannot have negatives up there, and you can't divide by x, as that would kick it out of being a polynomial. It's graphable, but it looks completely different than what a typical polynomial or roller coaster kind of graph would look like. Then we need to understand a couple things coming into this part. Is standard form is when which has been multiplied out. So this whole thing has been multiplied out for you, so it's kind of like written as a sum or a difference. This is factored form, and factored form is where I have 3 factored chunks that I need to multiply together. By the way, this exact equation down here equals this one up here. Okay, this expression equals this expression. They are mathematically equal. If you were to multiply these out using box problems, you would get this answer. So you just need to understand there's a difference between standard form and factored form. All right, the next one is the odd-even power rule. The odd highest power, odd, I want you to remember is opposite. Even, I want you to remember is the same. What I mean by that is the starting and ending arrows are pointing in opposite directions if it's an odd highest power. If it's an even highest power, even is same, then the starting and ending arrows are pointing in the same direction. So if you think about this one, this was even power. This power was a 2. Therefore, the highest power is a 2. That is an even number, so the arrows point in the same direction. Look at these arrows. This is a parabola. We graph it like this with an arrow on this end, an arrow on this end. They're pointing in the same direction. They are both pointing up because that's an even numbered power, with that being a 2. All right, the last one is the end behavior or orientation of the graph. Its positive stretch factor means the arrow would be in the upper right of the graph. A negative stretch factor, the arrow would be in the lower right of the graph. So if we take a look at this, we notice that there's no stretch factor number out here, so we assume that that's positive 1. Same thing here, there's no leading coefficient, so we assume that to be positive 1. Therefore, this area over here, it has to be in the upper right. This last arrow would go up. So notice that the positive stretch factor of 1, therefore the right side arrow, the last arrow, is in the upper right corner going up. All right, these are the 5 big key ideas. We've walked through them now. You should have those written down because now we're going to use them to try to build our graphs from our equations. So here we go. Equation to graph, building on what we already know. You already know some things, so we should be able to do this. So the first one is y equals x minus 4. Well, if we think about zero product property, when does this equal 0? Well, when x equals 4. So that's going to be pretty important. When x equals 4 is right here, that's at 4, 0. So what that's going to do is it's going to hit at that point because it makes it a 0. And you're going to end up getting a line right here. This is a line cutting through at 4. And I've zoomed in on that because I want you to really focus on what behavior is happening at the x-intercept locations. So we're having a line through 4 on the x-axis. That's a pretty simple example. That's just a line equation. Let's keep going. What happens if I keep that same x minus 4 and I also group it with x minus 7? Okay, interesting. Now what's going to happen is this part is going to make it hit at 4, which it does right here, 4, 0. This is going to make it hit at 7, so this is 7, 0, and that's the reason why. Now, you'll notice that it is a full parabola shape. Well, we already did one of those because if I multiply x times x, I get x squared. So this equation, if you really think about it, is an x squared kind of equation plus, minus blah, 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 and so on. But if we were to multiply these together, the highest power there would be a 2, which means this has to have 2 directions, going down and then back up, which you can clearly see that it's doing. But what I want you to notice is that it's making a line, right, through 4, and it's also then making a line through 7. So if I continue to go forward with this then, I'll notice that there is a line right here. If I zoomed in on this spot, I notice there's a line cutting through right there. A line cutting through. Then there's a line cutting through 7. There's a line cutting through because this is a first power term. Okay, next. Now we have 3 pieces. We have x minus 1, x minus 4, and x minus 7. Let's make a prediction of what we think this graph would look like. Well, you know that it's got to hit at 1, it's got to hit at 4, and it's got to hit at 7. So something simple I could do is I could say, well, I know it's got to hit at 1, so I'm going to put a dot like at 1. It's got to hit at 4, and I know that it's got to hit at 7, so then I'm going to put a dot there as well. So if I'm going to do that, then I'm going to notice that I'm going to have an x times an x times an x. If I was to multiply all these out, I would end up with an x to the third, plus and minus something else. So I know I've got to have 3 total directions. But if I look at the 1 individually, it's got to be a line right here. It's got to be a line through 1. It's got to be another line through 4 and a line through 7. So, and I notice out front here that I have a positive multiplier, like a positive 1 sitting out here. So I know my last arrow has got to be up. And then for it to be third power with 3 directions, that's an odd number. So if I have an odd number, then I know my first arrow is going to be down because the arrows had to be opposite. Then I need to make a line through those points. So I simply just go through it going like this with a line through there, come back down, make a line through there, come back down and go back up and make a line through 7. That's basically all you need to do to be able to draw the graphs. Is you have to know what shape is occurring at that point. So I know that at this first spot, this had to be a line because it was hitting 1, it was hitting 4, and it was hitting 7, which I made it do that. Then it was lining through each of those. This arrow had to be up because this was a positive 1. This arrow had to be down because there was a total of an odd number, and odd is opposite. So that's why I made the arrows do that. Let's keep going here. So this is what the graph looks like, okay? And then the way that I figured that out is I'm describing in detail now. If I zoomed in and only looked at this one spot right here, that would make a line. That's what this is showing you. It's cutting through as a line. Okay, same thing's going to happen right here at 4. It's going to cut through as a line. If I only look at the 4, that's a line. Same thing for the 7. That's making a line through there. So it's going to line, line, line. It had 3 powers. Therefore, you're going to see it up, down, up. That's 3 directions, which is equal to the number of degrees. If I was to multiply this equation out, if I wanted to take the time to multiply this whole thing out, it would make this equation down here, x to the third minus 12x squared, but I'm not asking you to do that. I'm asking you to understand how you draw the graphs. And we looked out front and there was a positive number, that's why this last arrow had to be up. And if I multiply these out, this highest power is 3, therefore it had 3 directions. So it was 1, 2, 3, and it's up, down, up. Okay, and then it was hitting at these 3 points because of these 3 numbers right here. All right, so the steps that we've walked through here, we're going to do a couple more examples, so if you're feeling confused, don't worry about it, is 1, you mark the x-intercepts, which we did that right away in the one I just showed you. Then the next thing you do, you determine if the right or ending side arrow, is it going up or is it going down? That's based on if you have a positive or negative stretch factor out front. So then you mark it. You just draw a miscellaneous arrow up in that corner or down. Then you count the total number of powers of x. If I was to multiply the equation out, how many powers of x would I had? And then I'm going to use the odd-even rule. The odd rule is opposite, and then the even rule is the same. So then I can figure out where that left arrow needs to be. Draw the graph using the proper shape at each x-intercept. Okay, so you want to look at each x-intercept and see exactly what it's doing. All right, so in this particular problem, what you should notice is you've got x plus 2, and then x minus 1 and x minus 3 squared. What is going on with x minus 3 squared? What is that going to do? Well, think about what shape an x squared makes. We haven't done one like this before, but it's going to do the same thing. So step 1, mark the x-intercepts. So I'm going to go over here, and I'm going to simply mark the x-intercepts. I know it's going to hit at -2, okay, because this one's going to be -2. The behavior at -2 is it's going to be a line, because this is a line type of a graph. And then at 1, I'm going to put a dot at 1. I know also that that's going to be a line as well. And then finally, I see this 3. I'm going to put a dot at 3, but I know what that's going to do is that's going to parabola. Okay, I know that that's going to parabola at 3 because it has a squared right here, and that's what a parabola does. Now, if I count the powers, this would be 2. Okay, if you're thinking about counting the powers right now, this is 2. This would make an x squared right here with these. And then times an x, that's x to the third, times another one, that's x to the fourth. So overall, this problem is an x to the fourth kind of a problem. So that means I'm going to have 4 powers. Well, that's even. So now I have to have 4 directions to my graph, which the arrows are going to be the same. I look out front, I notice that there's nothing here, so that's like having a positive 1. So this right-hand arrow is going to be up, and then I had even, which means this arrow also had to be up because those arrows are now going in the same direction. So this arrow is up and this arrow is up because we had an even number of powers. Then I just go back through and I simply do what it's doing at that point. At -2 is supposed to do a line, so I'm going to cut through as a line on -2. Then I've got to do a line through 1. Well, if I'm already down here, the only way to get there is to make a line like that. So it's going to curve down and it's going to go up through that. Then it's got a parabola at 3. Well, a parabola looks like this, so it's going to do something like this. So it's going to go up, come back down, it's going to parabola, it's going to look something like that when I'm done. That's what you should be seeing. That's how you build these graphs. So here's what it really looks like. So when you made that, you're going to notice that it's definitely doing what we talked about. It's going down 1, up 2, down 3, up 4. That's 4 total directions because this was degree 4. Okay, if you want to think closer, what is it doing? Well, you know that it was doing a line at -2, so if I zoom in right here, it's making a line cutting through there. If I zoom in at just this 1, that's a line. This is that box zoomed in. That's all you would see if you only looked at that 1. Keep zooming in. If I zoom in and just right here, which I did, I zoomed way in on this, and it looks like that. If you really get zoomed in, it looks like a parabola right there. And that's what this is saying. So this is making a line, line, parabola at those 3 locations. And if this last arrow up here is up because it was a positive number out front, and it was an arrow over here on this side because it was an even number of powers, because there was 2 powers of x, 3 powers of x, and 4 powers of x. All right, on this one, you should notice something, a couple of new items and notice here. There's an x out front. That means that x right there, what is that going to do? And then this one has a term that is cubed. Okay, well, it has a factor that's cubed, which that just means it's going to make a cubic at 4. Don't freak out by that. The x out front, well, when would this be 0? Think about that. We talked about these. I know that this answer is 1 because that would make 0. This answer is 4 because that would make 0. Well, then this just simply means it hits at 0. That's this point right here. It's going to go through 0, 0. We hadn't had one do that before. So now we're going to have one that hits at the origin, or 0, 0, because if you have a plain x out front, that's what it does. Okay, so here's what the graph of that looks like. So it's going to hit at 0, 0, which is right here. It's going to hit at 1 right there. Look at what it did at 1. Interesting. And now look at what it did at 4. It came up, it leveled out, and curved up again. That is a cubic shape. That's that S kind of curve that we've talked about before. So if you want to get into the details, we knew it had to be a line at 0. So if I zoom in on this, this is what I would see. That's what this is telling me. Then it would have to make a parabola at 1. That's an upside down parabola right there. So it's paraboling right there at 1. And if I go a little bit further, it had to cubic at 4. And that's what this is doing. That cubic kind of a shape is right there. That's what this is doing. Now watch me count this. Down, 1, 2, 3, 4, 5, 6. It has 6 directions because if I added up these powers, there's a 3 plus 2 is 5 plus a 1 power on this is 6. So the degree of this polynomial is 6. The directions it travels is 6. Down, up, level out, and then back up again. So 1, 2, 3, 4, 5, 6. All right. Next, a couple of new items in this last one. You should notice that we have a -1/2 out front. Ooh, that looks so scary. All that is a negative stretch factor. That's just telling me that the right-hand arrow is going to go down. So don't freak out by that. We also have an x out front again, so that means it's going to go through 0, 0. Okay, and we have 4 total x-intercepts. So that means it's got 1, 2, 3, 4 spots that it's going to hit for the x. So why don't you pause the video and see if you can draw this graph here before I put it on the screen. All right, we're back. So let's take a look at it. This is what it looks like. You have a negative number, so that means this negative should go down over here. It's got to hit at 0, so it hits at 0 right here. It's got to hit at -2 and do a cubic. It's doing -2 cubic. It's hitting at +1 squared. Here's 1 right here, and it's doing a squared. And then it's got to come back down and hit through 2 because it had to be negative because of this negative out front. If we think about those pieces or parts again, this is actually the first one you have to graph. I know the 0 was out front, but -2 comes before 0 if we're counting. So -2 is back here. So the first thing you had to do is -2 cubed. So I'm going to mark the -2, then I'd mark the 0, then I'd mark the 1, and then the 2. Now, after you do that, though, I'm assuming that you already put your negative arrow on, which was down here in the corner, and then you counted your powers. There was 1 power of x, 2, 3, 4, 5, 6, 7. 7 is an odd number. So that means I had to have one arrow go down because it was negative, and the other arrow had to be up because it was an odd number. So now watch this. It's going to go 1, 2, 3, 4, 5, 6, 7 directions because this had 7 total powers in the equation. All right, if you look closely, there's a cubic at -2. That's this guy right here. This is a line through 0. So there is your line through 0. That's what this is showing you. Okay, and then this is a parabola at +1. So I go to 1, there's a parabola. If you zoomed in on it, it looks like that. And then this term right here is telling me that I have a line through +2. And if I zoomed in right here at this +2, it would be a line. So I just wanted you to notice that the -1/2 out front is just a stretch factor. It's negative, so the right arrow is going to be pointing down. So you pretty much put that on your equation first. So when you go to draw this, the first thing you do is you put a negative arrow down here in this corner. And then because it was odd or -7 powers, then I'm going to put the positive arrow up here. Then I just go through and I just do what all the shapes are doing. That's what we've been talking about. So in conclusion, these were the 5 steps to be able to fully go from the equation to the graph. You mark the x-intercepts, you draw the right-hand arrow, you count the total powers, and then you use the odd-even rule to determine if it should be pointing up or down, and then you draw the graph using the proper shape at each one of the x-intercepts. All right, flipping gears, we're now going to have to go from the graph to the equation. So you can do this too. Think about it. If I give you this answer, you should be able to look at these points and go, I know what number is going to go in my equation. That number is going to go in your equation. That number is going to go in your equation. And if you think about what it's behaving right there at those points, you can then build the equations that we were just doing. So here's what I want you to think about. Where does it hit the x-axis? What is the graph doing at those points? Is the right side arrow up or down? and how many directions does the graph go? That's going to kind of be a way for you to check your answers so you didn't miss anything. Okay, so right now I can look at this. I can see it hits at -4, 2, and 4. That's what I'm saying here. Hits at -4, 2, and 4. So those numbers have to be in your equation. Next, what is the graph doing at each one of those x-intercepts? How is it behaving? Well, if you look closely at -4, 0, which is right here, it's making a line. It's cutting a line through the x-axis. At 2, 0, it's making a parabola. So right there, it's paraboling, it's bumping off. And then right here, it's 4, 0, and 4, 0, if I zoomed in on that, that would be a line cutting through 4. So it's a line, parabola, line. That's going to affect the powers we put on each factored term. Next, is the right side arrow up or down? Well, look at this down here. It's ending down, so that means this is going to have a negative. So the graph has a negative number out front, which is a negative stretch factor. That means this makes this arrow point down. All right, and then how many directions does the graph go? Well, it goes up 1, down 2, up 3, down 4. That means the total number of x powers has got to be 4. And that's going to be used to self-check. Okay, we'll take a look at this. I put a negative out front because this arrow was going down. Then I did x plus 4 because it was hitting at -4. You notice it was making a line, so I didn't put a power up there. Then on this one was a parabola, so then I put a 2 up there because it was paraboling at 2, and that it would be from x minus 2, would make positive 2. The next one is x minus 4, and so that's coming down here at 4, and it's making a line through 4. All right, then here's a new one. Where does it hit the x-axis? What is it doing? Is the last arrow up or down? How many directions does it go? So you can see -2, 0, watch out for that, and then +2. And it's a line through there, a line through there, and a line through there. And this is positive over here on this side. So here are the key factors. It's -2, 0, 2. It's line, line, line. It goes up, and it has 3 directions. Therefore, the equation would simply be, to get it 0, I need a plain x out front, and then -2 would be x plus 2, and +2 would be x minus 2. And there's your full equation. Okay, so here's a graph. Why don't you go ahead and pause the video and see if you can come up with this equation. Okay, we're back. So here's what you have. You have your key points as -4, 1, and 3. You know that it's a line, line, line through each of those, lining there, lining there, lining there. The last arrow is down, and it has degree 3. 3 directions. So look at this. We have a negative, and if I multiplied these 3 x's together, I'd get x to the 3rd power. This would be x plus 4 for that spot, x minus 1 for this, and x minus 3 for that. And then finally, I tried to put one that has all the possibilities at you. So see if you can do this one. Pause the video, give it a shot. Okay, we're back. So let's take a look at the key points. It's hitting at -2, 1, and 3. So -2, 1, and 3. It's doing a parabola on the first one. It's doing a line through the second one. And it's doing a cubic back here through 3. And by the way, that last arrow is up. And then it has 6 directions. 1 down, 2, 3, 4, 5, 6. So 6 directions is what we're looking for. So we're going to have 6 powers on our x's. Right here is 2 powers on this x. Here is 1 power on this and 3 powers on this. So 3, 4, 5, 6 powers. And so that's going to work. Okay. I noticed that the last arrow is up or positive, so I just left this as a plane. This was x plus 2 squared because it was paraboling at -2. And then it was doing a line at 1. That's why this is x minus 1. And it was doing the cubic through 3. That's why this is x minus 3 cubed. So in conclusion, to get from graphs to equations, you write down where the graph hits the x-axis because those numbers have to be in your equation. You need to recognize the shape that the graph makes at each of those x-intercepts because that determines your power. And then you look at your right side arrow. Is it up or down? That's going to determine your stretch factor being positive or negative. And then you build your equation. Now, some hints or reminders to remember. Make sure you put a negative sign out front if the right-hand arrow is down. And make sure you put an x out front if it does go through 0, 0. If your graph goes through the middle, 0, 0, the origin, you do need a plain x out front. And then make sure the number of directions equal the number of degrees in your equation. That's kind of a way I would use as a self-check. That is the main ideas for polynomials as you're getting started in this new unit.